All right, so we should be picking up on page 7. So we have some integration problems to try. Um, let's see how those go. So for the first one, we've got the integral of x over the cube root of x squared plus 3 dx. So for this one, we should be trying a u substitution. So that would be u du dx. So we're going to let our u be the stuff in the radical. So that's x squared plus 3. So the derivative of that is going to be 2x dx, which would make dx du over 2x. And then we can plug this in. So that would be the integral of x over u to the third du over 2x. The two x's are going to cancel, well, the x and the x are going to cancel, and it's going to leave us a 2 on the bottom, which is the equivalent of taking out 1/2. And then we need to flip our u upstairs. And finally, after all that, now you're ready to actually integrate. Okay. So from there, we can integrate this, and that would be 1/2 times u to the, if we add 1 to the power, that would be 2/3 divided by 2/3 plus c. So this is now 1/2 times, when you divide by your fraction, you want to flip it up. So it's 3/2 u to the 2/3 plus c. And then we plug our u in to be x squared plus 3. Cleaning this up, you've got 3 over 4. So it's 3 over 4 x squared plus 3 to the 2/3 plus c. Final answer. Anybody have any questions on that one? Okay. Next one. You want to split those up. So you want to write that as x to the 5th over x minus x to the 3rd over x plus 4 over x. So we split them up. Simplifying, you would have the integral of x to the 4th minus x squared plus 4 over x. Now you want to integrate. So that would be x to the 5th over 5 minus x to the 3rd over 3 plus 4 ln absolute value signs of x plus c. And if you made that natural log of x to the 4th, means the same thing. Any questions on that one or anything on this page?
Do you have to put the absolute value signs?
You are supposed to. That said, I do not think it will. I don't think it would be the difference between right and wrong, because it's usually, this would be like a multiple choice type question. So they should have that included for you. On the off chance that you saw 2 identical choices, then yes, you would want the one with the absolute value. It's just kind of like a technicality, because when you get into natural log, the answer can't be negative. So when you're backtracking into the answer, that's just like kind of like your way of saying it. In the grand scheme of the AP exam, this is not super important. Just something to remember as you, whenever you see it done.
Okay, thank you.
Mhm. All right, next up, we are finding some areas bounded. So let's make sure we remember how to do this. This is 100% on the AP exam, so we should be able to get this one right. Area bounded comes in 2 forms. One of them, they give you the bounds, like that one. The one below it, they don't give you bounds. So if they give you bounds, we just use them. Figure out what's on top. So if I plug 0 in, e to the 0 is 1. If I put 0 in here, I've got 0. Leads me to believe this is on top. If I put 2 in, same story. E squared is bigger than 2 squared. So the e function is going to be on the top. So remember the setup. It's the integral of the top function minus the integral of the bottom function. And both of these are from 0 to 2. Okay. And then remember I said if they have the same bounds, we can smush these together. So it's e to the x minus x squared from 0 to 2. Now we can integrate that, and it would give me the integral of e to the x is e to the x minus x to the third over 3 with bounds 0 and 2. Okay. Next, we want to plug in our bounds. So I'm going to plug in 2. So that would be e squared minus 8/3 minus, plug in the bottom. Don't just assume it's 0. It's not in this problem. E to the 0 is 1. And the second one is 0. All right, so that gives us e squared minus 8/3 minus 1. And that's how we're going to write our 1 is 3 over 3. So that's e squared minus 11/3. Final answer. Any questions on that one? Okay. If we look at the one below it, it's area bounded, but in order to get your bounds, if they don't give you bounds, we want to set things equal to each other. So if you set x squared plus 3 equal to 7, that's going to be x squared is equal to 4, x is equal to plus or minus 2. So if you think about what that looks like, that would be two different functions. We have x squared plus 3, looks like that. And then at 7, call that 7, you have a horizontal line. So you can kind of see the shape here, and then these bounds are at -2 and 2. So as far as the area between them is right there. So the function that's on the top, again, we got to figure out what we're looking at. The function that's on the top is the horizontal line. The function that's on the bottom is the parabola. So it's going to be the integral of the top minus the integral of the bottom. And the bounds are -2 to 2. So we're going to smush these together, and that's going to be 7 minus x squared minus 3. That's really 4 minus x squared when you combine the like terms of 7 and 3. After that, now we're finally ready to integrate. So that's going to be 4x minus x to the third over 3 from -2 to 2. And then you got some plugging in to do. It's going to be plug in the top. So that's 8 minus 8/3 minus plug in the bottom, -8. This is going to make a minus over here. So minus minus is going to make that a plus. And if this was multiple choice, which likely it would be, that means we got to keep going. So this would be 24/3 minus that. So I've got 16/3 minus Same deal over here. This would be minus 16/3. I'm coming up with 32/3 as a final answer. Any questions, guys, on area bounded? Okay. Next up, we've got some mean value theorem. Shouldn't be too bad. So to do mean value theorem, remember what we want to do. We want to draw a curve. So there's my curve. All right. And it's going from -1 to 2. If we plug those points in, if I plug in -1, I've got 1 minus 1 would be 0. If I plug in 2, I've got 4 minus 1, which would be 3. There's the regular slope I'm looking for. That regular slope would be 3 minus 0 over 2 minus -1, gives me a slope of 1. To find out where that tangent matches that secant, we're going to take the derivative and set it equal to the slope I want. Gives me a value of c equal to 1/2. Okay. Okay, so we've got all these questions down here about the normal and the tangent and all this and that. Did we talk about the normal line in class?
Yeah, I think we did.
Normal, perpendicular, that rings a bell? Okay, so the one that's perpendicular is called the normal line. Okay, so let me stop the share for a second here so you can see. All right, so we need to know this point right here. I need to know its y value. So I need to plug in 1/2 into the original. And the original problem was x squared minus 1. So if you put a half into that, it's really going to be a 4th minus 1. It's going to be -3/4 is that corresponding point. So they're going to ask you things like, what's the secant line? What's the tangent line? What's the normal line? So as far as this goes, if I ask you for the secant line, you could just use the point -1, 0, slope 1. If I ask you for a tangent line, the point is going to be a 1/2 comma -3/4, slope 1. If I ask you for the normal line runs through the same point as the tangent line. That point would be 1/2 comma -3/4. The perpendicular slope, what's the rule for perpendicular slope, guys? You take the tangent slope and do what with it?
You flip it and add a negative or reverse the symbol.
Yeah, exactly. So that's going to give me -1. If you turn 1 upside down, it's still 1. And then we just got to make it negative. So that's all the different information that could be coming out of an MVT type of question. Okay. Questions there. How did I get -3/4? I plugged in 1/2. So here's the point in question. I'm trying to find the y value for that tangent point. So I had said I know the x value. That's the value c, 1/2. So I plugged 1/2 into the original equation, and that gives me the y value that goes along with it. So if I plug in a 1/2, gives me a 4th minus 1, and then a 4th minus 1 is that -3/4. Okay. All right, good. So if this is all making sense, guys, we're making lots of progress. Okay, let's see what we got left. We got some integration and we've got some free response. All right, cool. So for the next one, from pi over 4 to pi over to negative e to the cotangent x over sine squared x dx. Okay, we need to clearly do u substitution here. Hopefully everybody would agree with that. So we're going to go u du dx, and we're going to let u be equal to cotangent x. So then if we take the derivative of cotangent x, you get negative cosecant squared x. So you got to know all 6 trig functions derivatives. Solving for dx, it's going to give me du over negative cosecant squared x. Okay, so we plug this in. So this is the integral of negative e to the u. On the other side, you've got du over negative cosecant squared x. You can write this sine squared x in, but you have to see the trick. And the trick to the problem is saying that I can flip this trig function, sine squared x. I can flip it upstairs. So remember what happens with trig functions when you flip them upstairs. If I scratch this out and I bring it up top, it becomes its reciprocal. And the reciprocal of sine is cosecant. So now you can see the negative signs are going to cancel. The cosecant squareds are going to cancel. And that just leaves me with e to the u du. So we still need to integrate all that. But before we get any further, does anybody have any questions on the setup before we integrate and plug in? Okay, so if you integrate e to the u, that's e to the u. Bounds. Pi over 4 is on the bottom. Pi over 2 is on the top. And we also need to plug in for e to the u. So e to the u is really e to the cotangent x. Okay, so this is e to the cotangent pi over 2 minus e to the cotangent pi over 4. We need to know what's what here. Cotangent at pi over 2. Pi over 2. What do we know about that value? It's what? Somebody.
Would it be 0?
Yeah, it would be 0.
Oh.
So e to the 0 is 1 minus cotangent of pi over 4 is just 1. So the answer is 1 minus e. And there's all the work behind that problem.
We're gonna take a picture really quickly.
Yeah, I'm trying to zoom out so I can fit all this in here for you.
Okay.
That's pretty close here.
Okay, thank you.
Okay, so I'll leave it up there for 1 second in case anybody else is taking a picture. What do you think, guys? Make sense?
Yep.
Okay. All right, let's go back then to our shared screen. And oh boy, the next problem looks way easier compared to that. So if you integrate cosine, we don't need to do anything for this one. So what do we get if we integrate cosine?
Side.
Yeah, this is about the biggest change in difficulties you could come up with. Sine. And then that one has bounds of 0 and pi over 2. So this is the sine of pi over 2 minus the sine of 0. I'm coming up with 1 minus 0, giving me 1 for an answer. I'm assuming there's no questions on that one if you didn't have many to ask on this one. So, all right, on to the next part of free response. So, like always, you want to read the free response question. You want to see what you can get out of it, see what we're talking about. Temperature of water It's modeled by the twice differentiable, yada, yada. We don't care. It's modeled by W of T. So W of T stands for the temperature of water. And if you look at the temperatures, it looks like they're going down. So something's cooling off. Okay. At time, what happened here? At time, should say T equals 0, I think. Yeah, it should say at time T equals 0, the temperature of water is 80 degrees, which that checks out of the box. Okay. The water cooled over a 20-minute period of time beginning at T equals 0. Yes, correct. Okay, I don't know why that wasn't there to begin with. Okay, and values of WT are selected above. Okay, long story short, you've got a bunch of temperatures. Something's cooling off. It's modeled by W of T, and it's written in a box. Using the correct data, estimate W prime of 15. Show the computations that lead your work to your answer, yada, yada, yada. Okay, you should know how to do this. It's the same part A as all of them. So what are we doing in part A?
You would find the slope of the points.
We'd find the slope. It's the same thing we've done in every other part A. So it's going to be W prime of 15 is approximately equal to 40 minus 60 over 20 minus 10 equals negative 20 over 10 equals negative 2 degrees per minute squared. Any questions on A? All right, let's talk about part B. Somebody tell me what's going on in part B. This is a little tricky. What do they ask us to integrate?
The whole table.
Do they? What does it say to integrate? Integrate
Oh,
what?
wait, no, it's saying integrate the derivative, so it's just.
It's asking me to integrate W prime, but do I have W prime?
No, but
I
the
have
integration
W.
of prime is the same thing as the regular thing.
So is this area under a curve type of problem, or is this FTC?
FTC.
FTC. So this is, when you integrate this, it's just W of 20 minus W of 0, which is equal to W of 20. We can look that up. It's right here. W of 20 is 40. W of 0 is 80. That gets you your answer of negative 40. Okay. All right, using correct units, interpret the meaning of that. So what is the meaning of that? It's going to be, what is that 40 minus 80?
It's how much the whole thing's heated up, right?
Not heated up, but
Well, I mean, since it's negative, you would say heated up because you wouldn't say it's cool negative 40.
That's an interesting interpretation. Using the data in the thing, evaluate that. So it's still going from, I guess what I'm getting at is the end result is, if you look at the table, the end result of this is still, we're going from 80 to 40. So it's got to be something about cooling off. Let me read it to you word for word. Give me 1 second so that we're on the same page. Yeah, I think you can make that argument. So the problem that they had released, so this is a different version of the problem. This came from a 2012 AP exam, and in their problem, it had been heating up. So I still think we want to use cooling off, but I think you can just say it cooled off by 40 degrees. Because the overall gist of the problem is that it's going down by, it's cooling off. Does that make sense?
Yeah.
Okay. Okay, so yeah, that's the gist of what they want here. But the big thing, the really important thing is that we know integrate W prime gives me W, and this is FTC. All right, part C, what do we got? Is there a time between, remember I told you yesterday, you're gonna see this like 20 times and eventually it'll start to make sense. Is there a time between 5 to t to 10 such that the derivative slope is -2? Is there a time from 5 to 10 such that the derivative slope is -2? What kind of problem is this?
MVT.
MVT. What did I tell you yesterday? The answer always appears to be based on my knowledge.
Yes.
Yeah.
It's always yes. Let's just start with that. Yes. Because the function is differentiable and therefore continuous by the mean value theorem, there must be a place or a time where W prime of t equals, would they ask for -2? -2 on 5 to t to 10 because, and then my because is going to be we're showing the slope. So I'm going to find that secant slope. And how do I find the secant slope? Always just use the endpoints they give you. So I'm going to use 5 and 10. So if I use these points right up there, it's going to be because 60 minus 70 over 10 minus 5 equals -10 over 5, and -10 over 5 is -2. Okay. All right, so to better explain that, here's all they're saying. Pretend this is the graph, and they're asking you from 5 to 10. And it says, is there a time on 5 to 10 where the tangent slope is -2? And I'm saying, if we would happen to find a secant slope that was -2, wouldn't the definition of the mean value theorem tell me that there is a tangent slope also being the same thing? And I'm just telling you that every time they ask this question, it's yes, it's MVT, and then use the endpoints they're given or they're giving you to locate your slope. And it always checks out because they don't want you to be looking forever. They just want you to understand the idea of the mean value theorem. So, hey, that's 2. Yup, that means somewhere else there's a tangent slope that's 2. And all you're doing is this is just the justification of the mean value theorem. So it's yes, because the function's differentiable and therefore continuous by the mean value theorem, there must be a place where W prime of t is equal to -2 on that interval because 60 minus 70 equals 10 minus 5, or over 10 minus 5 gives you that slope. Okay. Any questions there, guys?
Can you also use A to give you -2, like the 40 minus 60, since you already did all that math in A, as opposed to doing 60 minus 70 over 10 minus 15 or 5?
No, because for part A, let's go look at that. That's a good question. Check out what we did in part A. Part A, we used 10 to 20 for X values, right? And in this particular problem, it's very clear that it says, is there anything between 5 to 10? So does that make sense that A is looking at a different part of the problem?
Yeah.
So whenever you're doing a mean value theorem, just stick to the endpoints of the interval that they give you, and it'll always lead you right where you're trying to go. Okay? takes us to part or page, whatever, page 12. This should be easy, I'm thinking, right? We've done lots of problems like this over the year. We shouldn't have any problems here. Is it okay to use abbreviations on the free response? You're more than welcome to do it when you're sending stuff to me. I would not abbreviate things on the actual AP exam. Like MVT, yeah, you can do that. But I wouldn't be saying all this text message slang, B/C, and abbreviating differentiable and continuous like this. I would write all the main words out, just because there's no guarantee who your grader is and what they will or will not recognize. Okay, what do we have here? We have the graph of F, and we have a table for G, so this should all look super familiar. And in part A, we are being asked to find H prime of 1. So if I'm going to find H prime of 1, I should start by taking the derivative of that. So that would be H prime of 1 is equal to, well, we're not ready for that yet because we need a derivative. H prime of X is equal to G prime F prime. Okay. Okay, so what do we do next? Now we're plugging in a 1. So this is H prime of 1 is G prime F of 1 times F prime of 1. So where do we find all this information at? We find it for F, we find it on the actual graph. We have the graph of F. F of 1 is 0. So now that's G prime of 0 times, what is F prime of 1? F prime of 1, how do we find that, somebody?
It's the slope of the graph.
Perfect, slope of the graph. So the slope of this graph is what? Up 2 over 1, up 2 over 1, we're good with 2. And then the last thing we need is G prime of 0. G prime of 0 appears to be 3 times 2. Final answer, 6. Any questions on part A? Okay, on to the next one. They ask us to find, I don't think they asked you to find anything. It was supposed to say find A prime of something. Apparently the directions were chopped off of this. So it was, did somebody message me? What did I tell you to find? Anybody? What did somebody do? Anybody do anything that worked on this? Okay, well, we're gonna try A prime of 1 and see what happens. All right, I might need to change that, but we'll see. So we're gonna take a derivative through the quotient rule. So that would be A prime of X. Always make sure you write what you're finding. A prime of X is equal to, that's gonna be bottom, derive the top, minus the top, derive the bottom, over the bottom squared. All right, so
Breaker, I think would have to be
definitely can't be.
2.
Yeah, I just said that, just was about to say that. That's not gonna work. So let's try 2. You're right, because F of 1's no good there. All right, let's try that. So we're gonna plug in a 2 for all of this. So, all right, F of 2 is 2. G prime of 2 is 4. G of 2 is -1. F prime of 2 f prime of 2, that still lands on this line, guys, right? So even though it's at the end point, that's still part of this line, so that still has a slope of 2. And then on the bottom, f of 2 is 2 squared. You can leave your answer just like that, but we can figure it out if you like. That would be 8 minus minus is a plus over 4. That's 10 over 4, 5 over 2. Okay.
And Mr. Baker,
Yes.
so leaving it just like that will work on the AP exam?
If it's free response, yes.
Oh,
If it's one of the 6 free response questions, yeah, you'll get credit for that. You just can't leave any variables in there. But as long as you've plugged in for everything and the only thing left to do is just hammer out some arithmetic or math, what have you, yes, they would give you credit.
okay, thank you.
Biggest places that'll be useful is Riemann sums, quotient rules. Anytime you have a Riemann sum or a quotient rule in the free response, that's going to be the areas where you're likely going to just leave it and put the units after it or whatever the problem's talking about. Okay. Okay, so that's the end of page 12. So that's a lot of calculus. Looking back on this now, any questions or anything you want to talk about or look at again? If that whole test makes sense, or even 80, 90% makes sense, you're in a great place. We still got 2.5 months to go. I got to teach you some stuff, but if that's all making sense, we're doing good. We're going to be just fine. Questions, comments, anything you want me to do? Okay, Bennett, you can turn it off.